Stanford University.
Okay, well, welcome to lecture number, I don't know what, maybe 11? That's towards the middle of the quarter I start forgetting which one we're on, but at least hopefully I remember the content of that lecture, but which number, I don't know. So this is lecture 11, I think. Today we're going to talk about the location of the device, both how to find out where the device is, all right, and also how to display locations on a map. Okay, so we're going to do both sides of that, and then I'm going to do a demo at the end, and then your homework will be, part of your homework is to add maps into your assignment from last week. All right, so there's two frameworks involved here, two different frameworks. The first one I'm going to talk about is core location. The second one is MapKit. The core location is not a UI thing. It's just about finding the location of this device. And there's a lot to learn about the device because most of the devices, and especially the newer devices, have a lot of location devices in them, right? Magnetometers, accelerometers, gyros, GPS, all kinds of, wireless, all kinds of things to find out where you are. So there's a fair amount of API here. I'm not going to go into all this API in detail. Some of it I'm going to skim by pretty quick, just so you know it's there. But if you want to use it for your final project or whatever, you'll know it's there. So core location, the first of these two frameworks, has no user interface in it. It's just for locations and headings. The basic object in core location is a CL location. Okay, CL is core location, library prefix. Location is the basic object. And so the properties on a CL location are things like the coordinate, the GPS coordinate, even altitude, right? The accuracy of this location reading, which we'll talk about, timestamp, when this location was taken, speed, how fast you're moving instantaneously through GPS coordinates, and course, which is like where is your heading as you're moving along. And so the most important thing is the coordinate probably, and that tells you where this CL location is. And notice that I put in parentheses there approximately. Okay, that's because there's a lot of different ways to get your location, and some of them are more accurate than others. And we're going to talk about that in a moment. And so you can see that it's just a simple C struct. This thing called coordinate, this property coordinate on a CL location object is a C struct that just has latitude and longitude. CL location degrees, that type def is basically a double, okay? Floating point number, latitude and longitude. And altitude is in meters, okay? So you can get the altitude as well. If you have a negative altitude, that means below sea level. So let's talk about this accuracy business. So how close is the latitude and longitude that's in that coordinate property inside of a CL location? How close is it to the actual location? So there's another couple of properties on CL location called horizontal accuracy and vertical accuracy, which tells you in meters kind of how far off this thing could be, right? So there are you don't really look at this as a number in meters, like 27 meters. More you look at these predefined values, like accuracy best for navigation. That would be constantly updating GPS. All right, if you want that kind of accuracy, you're probably going to want your phone plugged into your cigarette lighter in your car or whatever, because it's going to use a lot of power. GPS uses a lot of power. Right? Constantly reading these things. Question?
Why do they distinguish between horizontal and vertical accuracy? Wouldn't those always be the same?
So the question is, why do they distinguish between horizontal accuracy and vertical accuracy? No, they wouldn't always be the same, because certain location measuring devices can't tell altitude, right? They can only tell horizontal. Okay.
Vertical, like 3D.
Vertical is 3D. Okay, so GPS could do vertical, but some of the other ones can't, and you'll see that in a moment here. So some of the other accuracies, best is still probably GPS, and none of these are guaranteed to be a certain kind of accuracy. These are just, you kind of infer from their name, that's what they're implying. But best would be best, but not constantly updating GPS that's going to drain your battery if you're not plugged in to your car. Nearest 10 meters is exactly what you think. It's kind of around here. 100 meters is, this quad, the engineering quad, so you're somewhere in this area. Kilometer and 3 kilometers, that would be things like using cell towers and things like that. That kind of accuracy, very, very rough. Okay, so how do you know what to ask for? Because you're going to be able to ask for a certain accuracy, and then you're going to get some certain accuracy with your locations. And you don't really ask based on knowing what technology is going to be used, but I'm going to tell you right now approximately what technology is used. So for best, it's GPS, okay? And most devices have GPS in them. Not all, but most devices have GPS in them. The next best is Wi-Fi. So believe it or not, your device can look around, see what the local Wi-Fi nodes are and how strong the signal is, and look up a database on the internet and find out where you are. Okay? So not using GPS or cell towers, just using Wi-Fi, kind of triangulating from local Wi-Fi. And that's reasonably accurate, especially a place like Stanford where there's an enormous number of Wi-Fi nodes. Okay, just Wi-Fi nodes everywhere, so you get a lot of triangulation points. So that's how you might wonder, how when I'm indoors, protected from the satellites, does it know where I am? Well, it can use Wi-Fi to do that. And then the third and least accurate is the cell tower. Obviously, it can see the cell towers near you and knows by that approximately where you are as well. Now, the choice between accuracies is all about power. Okay, GPS is going to use a lot of power. Cell towers, almost no power, very, 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 very little power. That's very highly optimized to be very low power. And so you can kind of pick what accuracy you need for your application, but don't go overboard and pick more accuracy than you really need. Okay, because it's going to cost power, it's going to cost your device's battery going to run down, your users of your app won't be very happy. All right, so what else is in core location besides the location and the accuracy of that? Sorry, question first.
Is there any way to see if a phone is plugged in and decide based on that which accuracy?
Yeah, so the question is, can I tell if I'm like plugged into the car and thus I have enough power to use a high power accuracy device? And I think the answer to that is no. But the thing about it is it depends on, if you're writing an app like TomTom, which is an inside your car, tells you the turn-by-turn navigation, you can pretty much assume the person is going to plug it in. But if you're doing something where you're going around the Stanford campus and maybe you're nearby something, it's going to give you a reminder like the Reminders app can do now, that'd be something where you wouldn't be constantly checking the GPS. So in other words, no, you don't want to involve the user in that, I don't think, by trying to outguess what they're doing, right? You're either providing that turn-by-turn navigation or you're not, right? You're providing lesser. So no matter how much power it is, you're providing a certain level of service. Okay, so what else can you get out of core location? Speed, course, timestamp, these are all pretty obvious things. Understand that these things are kind of instantaneously measured. Things like speed, it's just looking at the last certain number of GPS locations it found, for example, and just seeing what the time difference was and calculating the speed. So these are kind of advisory things. If you're driving in a car, it's probably going to be pretty accurate. If you're going down the road at 35, it's probably going to tell you, oh, you're going about 35. But if you're walking around, it's not going to say 2.7 miles per hour or 1.9. It's not that kind of level of accuracy, okay? And if these things are negative, usually it means that it's invalid. And course is heading. All these things are intentionally abstracted APIs that aren't telling you, oh, I'm looking at the magnetometer right now. Okay, I'm looking at the GPS differences. Okay, it's just reporting to you the best information it can with the hardware you have, because again, your app is going to run on different hardware. But you are going to care what hardware is available on your device, and as you'll see, and you're going to adapt your algorithms accordingly. So, and we'll talk about that in a moment. So how do I get a CL location, one of these core location and location objects? And the answer is you're almost always going to get one from another object called a CL location manager, okay? And I'm going to spend the next few slides talking about how we get a core location out of a CL location manager. But one thing that's important to note in iOS 5 is that you can actually simulate your location when you're in the simulator using this little menu that appears when you run in the simulator. You've probably seen this little thing. And you can basically pick a location on Earth to pretend you're at. You can even have your own little GPX file, which is basically a simple XML-like format to encode a bunch of latitudes and longitudes. And so you could even simulate moving around and stuff like that, okay? This is new for iOS 5. It was very difficult to debug anything that had to do with locations. In iOS 4, you had to basically go out and drive around or bring your computer with you. It was kind of tough. Or do something internal to your app or whatever. But now you can do this in Xcode, which is kind of cool. All right, so CL Location Manager. Okay, 4 things to think about with CL Location Manager. You got to do all 4. The first one is you want to check to see what hardware is available. Okay, and we'll talk about why that is and why this is a step you should not skip. 2, you're just going to create one of these CL Location Managers and set yourself as the delegate, right? Set some object as a delegate because the CL Location Manager is going to use its delegate to give the updates. Then you're going to configure the manager to what kind of location updates you want, right? Heading or just location movement, those kind of things. Also, there's different kinds of location monitoring too. It's not all just tell me where I am all the time. There's quite a bit of flexibility there. And then when you've got that all set up, you're going to do number 4, which is you're going to start it monitoring. And when you start it monitoring, it'll start sending message to the delegate, depending on how you've configured it. All right, so what kinds of location-based monitoring are there? There's accuracy-based continual updates. That means you set the accuracy, and then it will continue to update you as the person moves around within that level of accuracy, right? So if the accuracy is low, then it's not going to update very often. You'd have to move pretty far, but if the accuracy is high, it might be updating you quite a bit. Then there's also updates only when significant changes occurs. This is basically moving to different cell towers, okay, that level. And there's something really cool about that kind of updating. Then there's also region-based updates where you define a region on Earth, and when the person crosses into that region, you get an update. And then, of course, there's heading monitoring too. It'll just report when the person, turns their device pointing in a different direction. All right, so step 1 was to check and see what your hardware can do. These are some of the examples you have to look through and see what they are. You have to check things like location services enabled because the end user who's running your app, when you start asking for this stuff, they're going to get an alert put up by the system that says, this app wants to use your location. You've seen that, right? And if they say no, then location service enabled for you is going to come back and say no. Okay, so you have to check this because you might be saying, oh, okay, fine, I'm doing location services, and then it's like, I never get any updates. Well, that's because the user said no. Okay, so you need to adapt to that. Same thing with region monitoring, significant location change monitoring. You have to check and see if these things are even possible on your device. Not all devices can do some of these things. Yeah?
Can you ping the user again if they say no, like, are you sure? Maybe a few months later or something?
Yeah, that's a good question. The question is, if the user says no, don't let this app use the location services, can you ask them again? And I'm not sure what the rules on that are. They can always go to their settings and enable you. Okay, so they can do that at any time. And so at the very least, you could put up an alert that says, I can't get your location service because you disabled it. Go to settings and re-enable. Okay, and so they can always go to settings and do that. When the system asks you, by the way, or asks the user, your app wants to use the location services, it's going to put this string right here, this purpose string on the CL Location Manager instance, and that's going to be in the alert. So that's going to explain why this app wants to use your location service. So the purpose might be to tag your images with your GPS location. That could be your purpose, right? So you just set this purpose string in your CL Location Manager, and then when you start monitoring, if it asks the user that, it'll use this string. Everyone understand what's going on there? Question? No? Yeah?
Is there some sort of limit on how much information you can get about a user's location? Or can they have a halfway ground, like you can see within a cell tower, but you can't see within?
So the question is there a way that the user can kind of give his location away, but maybe not his exact location, just kind of a general location? And I don't think that granularity is specifiable by the end user. You could obviously have some API that says to the user, oh, I'll promise I'll only look in this thing, but there's no way to enforce it if you're the end user. If the end user allows you to do location services, pretty much you can get their GPS location.
And is there any privacy policy about that, like what you could do with them?
Yeah, there is a privacy policy. The question is there a privacy policy or something about the information you can do from a user? And there definitely is. In fact, this might be a good time to mention that at Apple, there's a lot of policy documents, okay? Things that they advise you about how to do the user interface, things that they will enforce when it comes to approving your app on the App Store even, okay? So you're going to want to eventually be checking out all those documents. Let's get to the point where you can write these apps first, and then you can start checking out the policy documents. So once you've checked to see what the hardware can do, now you can get the information from the CL location manager. Now you can just ask it for the location, tell me the current location, but usually you don't do that. That would be polling it. You don't usually poll it. Usually you set its delegate and then set the accuracy that you want, okay? And you want to set this as low as possible so that it's not having to use a lot of battery to be constantly checking where you are. And then you can also set this thing called a distance filter, which is don't give me another update until the person goes at least this far away from where the last update you gave, right? Which can also keep the number of updates down. So you set these, and then you just call start updating location on the CL location manager, and it will start sending messages to your delegates. And this is the main method that it's going to send, which is location manager did update to location from location. It's going to send you a new CL location object. It'll also send you the last one that it sent you. So that you can track what the user is doing. It's really quite simple to use. The delegate has other things, and we'll talk about those in a moment. Heading monitoring, I'm not going to talk about it too much, but it's basically the same kind of thing as location monitoring. You're just monitoring the heading. And so it has like a start updating heading, and the delegate method is location manager did update heading. Okay? And when it gives you a heading, what does a heading look like? Just like there's a CL location object, there's a CL heading. The CL heading has both magnetic and true, although you won't get true if the location services are turned off, because if location services are turned off, in other words GPS and Wi-Fi and all that, all it can give you is what the magnetometer is telling you, which is magnetic, right? It has to know where you are on the Earth to give you true. You may not know about the difference between true and magnetic heading, but just believe me, you got to have the location service have to be on, or you can't get true. You can only get magnetic. You've probably seen with the magnetometer, sometimes it puts up a thing that says, move your phone in a figure 8. Have you ever seen that before? That's so that it can kind of measure local magnetic interference, right, in the magnetometer. And so that's automatically done by iOS, although you can prevent it from doing that by doing this location manager should display heading calibration, returning no from that. If it's up or you want to go do something else in your app, you want to show the user something else and you just want that thing off the screen, whether they've done the figure 8 or not, you can dismiss it as well. Okay? But you don't have to do any work to put that figure 8 thing up. You will get errors reported, and you shouldn't just ignore this delegate method. A lot of times you get errors and it's kind of like, well, there's an error, too bad, I can't do anything about it. But this one, there's things like they didn't do the figure 8, and so I can't get good heading information. Then you'll get that error, and so you'll know that that's what happened. The figure 8 didn't happen. Or you'll get the error that it was denied. Okay, right? The user said, no, I'm not giving you location services. Okay, so pay attention to that delegate method. All right, so that's for just accuracy-based getting updates as we move around. But there's another couple of kinds of location monitoring. One is called significant location change monitoring, which is really, really cool because it monitors only big changes in location, like basically driving around kind of location changes, cell tower changes. But the cool thing is your app doesn't even have to be running. Okay? Once your app registers to start receiving these significant location changes, if it gets killed or the phone gets rebooted and it's not running anymore, or if it's running in the background, some other app is running, you'll get launched into the background and sent the message, application, when you get launched, application did finish launching with options will be sent to your application delegate, which we haven't really talked about, but suffice it to say there is this app delegate. You've probably seen it every time you create an app. You get this little app delegate.m. Well, one of the methods in there is application did finish launching with options. And if your app gets launched because of a significant location change, you'll get it with this key, UI application launch options location key. And then when you get that, you can go get the location, ask for the location that happened. If your app is running but it's in the background, you'll just get normal delegate method. You'll get woken up, because normally you can't run in the background unless you're a special kind of app. But if you turn on the significant location changes, then if a significant location change happens and you're in the background, your app will still get its delegate method. You'll get woken up. You won't come to the front and be the front app, but you'll be up and running in the background, and you'll get your delegate method, and you can do something. Now, you're only going to run for a few seconds in the background. It's okay, so you can't just sit there and start churning and doing all kinds of stuff, putting up a bunch of UI and stuff, but it's pretty cool that you get woken up. And similarly, there's this region-based thing where you specify a region, and when you go into that region or you go out of that region, you get an update. Same thing. Even if you're not running, you'll get these updates. Okay? And so these are the delegate methods you get: did enter region, did exit region. So this is pretty cool technology. This only works on newer phones. I think iPhone 4s. I'm not sure, iPad 2 maybe. I'm not 100% sure of which thing. And you can find out because you're going to ask the CL location manager with those class methods, does this thing do region monitoring? You'll know. But there's that. All right, the regions. I'm not going to talk a lot about the regions. These CL regions, which is how you specify a region, they're tracked by name, again, because they have to survive launching and relaunching, and you can control the limits of it, etc. So that's core location. Okay, that's basic locations. Now we're going to talk about MapKit, which is a different framework, which is how you graphically display locations using this Google Map technology. And the main class in MapKit is MKMapView, and it's just a UI view, okay, that displays a map, like you see there. Now, on the map, you have what are called annotations. All right, so the map view has a very important property called annotations, and it's just an NS array of objects that implement the MK annotation protocol, which we're going to talk about in a second. And that protocol is just a coordinate, a title, and a subtitle. And so the annotations appear on the map with some using an MK annotation view, which we'll also talk about. So in this case, they're showing up as pins. You see these red pins are showing the annotations. And then annotations can also have a call out. So when you click on the pin, a little kind of grayish rectangle can come up, like this one up here, and present some information, like it's going to present the title and the subtitle all the time. The title's the big bold white, and then the subtitle's the smaller font. But it can also have a left and right call out accessory, like this image and this little button. Okay, so we're going to talk about how to make all that work. All right, so how do you create a map view? You usually drag it out from Xcode, right? Just drag it out of the object library into your thing. Boop, you got it. Okay, you can alloc and init it, of course, but we don't usually do that in iOS 5. And then there's this property, this NS array of annotations. Okay, so that's an NS array of ID angle bracket MK annotation objects. So they could be any class of object in there, but they have to implement this MK annotation protocol. And so this is not delegation. This is a different use of protocols, okay? This is just defining what an object can do. Yeah?
Does it actually force you to like make each object you put in that array implement that protocol, or is there a way to say all the objects in this array implement this protocol?
Well, the question is, does something, the compiler or something, force you to make this array contain ID MK annotations? And the answer is no. Remember that NS arrays just contain IDs, right? So when you pass objects, when you add objects to this annotations array, which this is a read-only array, by the way. I'll talk about how we get things into this array. But when you pass it in there, the compiler really can't go and look inside and see if everything. But when the map view pulls them out, it's going to start sending them MK annotation methods, right? Methods in that protocol. So they better be, and if they're not, it's going to crash at runtime. Okay? So there's your answer. So what is in the MK annotation protocol? There are three things. One of them is required, which is the coordinate. And that's just a CL location coordinate 2D, which we saw a few slides ago, which is just latitude and longitude. Okay? The other two are optional, title and subtitle. All right? Simple as that. That's all there is to it. So the burden of these objects that go into that annotation, implementing them is a very slight burden. It's just these three things. So yeah, so I said note that annotations is read-only. Okay, people try to say map view dot annotations equals, and then they get a compiler warning. You add annotations by calling add annotation or add annotations, and you remove them by saying remove annotation for a single one or remove annotations for an array of them. Okay, so that's how we add them. So if we're going to replace all the annotations, which I'm going to do in the demo, for example, first I'm going to remove them all, then I'm going to add all the new ones. Okay? And it's generally a good idea to put all your annotations in there at the beginning because the map view is kind of like table view in that it reuses those pins. Okay? So if you put them all in there, it knows where all the pins go, it can be a little more efficient about knowing which ones need pins right now because they're visible and which ones are not, and creating enough of them so that they're available and all that business. All right, so just a little more about what the annotations look like on the map. You can see that the pin, the MK pin annotation view, which is a view that's in MapKit, is the kind of default one, and that has a couple of properties on it you can look at, like you can set the color of the pinned purple or blue or red, I think are the choices. So that's kind of the default, but you could create your own subclass of MK annotation view as well. And one of the properties in MK annotation view, the base class, is image. So you could set the image to be whatever you want. So pin annotation view sets the image to be a pin, but you could set the image to be something else. Don't get confused between the image that the MK annotation is using, like the pin image, and the image like of Memorial Church there. You see the little image in the call out? That's a different thing. Okay, that's the left call out accessory there. So what happens when you touch on a annotation view? We said this call out comes out, right? And in addition to that call out appearing, and we're going to talk about how we can control what's in that call out, you also get this very important delegate method. So the map view has a delegate, and very often you want to set the delegate so that you can get this message, did select annotation view. And it just gets sent to you whenever that annotation view gets clicked on. And remember that the annotation view knows what annotation it's viewing, so you can also get to the annotation that got clicked on as well. All right, I'll show you in a couple slides what an implementation of this delegate method might look like. So how do we create these MK annotation views? Again, if you don't do anything here, you're going to get the pin. And when you click on the pin, you're going to get a call out with the title and the subtitle, and that's all you're going to get. Okay, that's the default. But if you want to control what's going on, what's in that call out, or what the thing looks like even, you can implement this delegate method in MapView called MapView view for annotation. This is very similar to table view cell for row at index path, right? Very, very similar concept here. It's going to call this every time it needs to display a certain annotation in the map. It's going to call this to get the view to use display it. All right? So just like table view, we also have this dequeuing thing. All right? So notice that I create the view that I'm going to return in this delegate method by saying sender, which is the map view, dequeue reusable annotation view with identifier, and I give it some identifier, some string. Now, there's no way to do the like prototype thing like we have in table view. You know how in Xcode we had a prototype cell so that if we do dequeue and the pool of dequeue things is empty, it'll create a prototype copy for us. Can't do that with map view. So this dequeue will return nil the first bunch of times you call it, in which case you got to create your own view. So here, notice I'm using mkpin annotation view to create my views for my annotations. And the designated initializer for MK annotation view takes the annotation that you're creating the view for and a reuse identifier. I always thought it was kind of weird that this took the annotation because these things are going to get reused, and so you're going to set that annotation to something else next time it's reused anyway. So I always thought this should just be init with reuse identifier, but it is what it is. I noticed this is an old slide. It still has auto release in there. I will fix that. We don't need auto release anymore. That was iOS 4. And then probably inside here, you're also going to say this view can show callout equals yes. Okay, if you don't say can show callout equals yes, you won't get the little callout when they click on it. Okay, nothing will happen when you click on it. It will call the did select annotation or whatever, but it won't give you the default callout. So you almost always want to say that can shows callout equals yes. And then outside of this curly brace, okay, so maybe now a view is either created or it was dequeued. Now we're going to set the annotation. So it seems like we're setting the annotation twice, but not in the case of dequeue. We're only setting it once in that case. And then additionally, if our annotation view had a call out, some accessory views in its call out, like that image or some other stuff, then we would load that up here too, maybe. And I say maybe because if it's expensive to load up, we probably wouldn't do that. Then we would wait until someone clicked on the thing, and then we'd load the call up. All right? Everybody cool with this? So this method is just like cell for row and index path and table view. You only need to implement it if you don't want the default pin with the call out of title and subtitle, which unfortunately for your homework, you need more than that default. So you will have to implement this method in your homework. Okay. All right, so MK annotation view, this view that you're being asked to create in MapView view for annotation, that method on the previous slide, has a lot of methods in it. Probably it has that method image. That's the image that's the pin. Again, don't get confused. That's not the image that's like Memorial Church in the callout. Then it's got left and right callout accessory views. Okay, so that's views you can put on the left and right of your little callout box. So this is where you would put a UI image view probably on the left to have Memorial Church, and you might put a button on the right to be your right callout view. And there's other things here like, the pins can be actually draggable. You can make them draggable inside. If you make a pin annotation view, set it to be draggable, then they can pick the pin up and move it as long as your annotation implements set coordinate as well as coordinate. Otherwise, setting draggable means nothing. One cool thing is if you set either of the callout accessory views, okay, the left or right view that appears in the callout, if it's a control, like a button, okay, button inherits from a class called UI control, then when someone touches it, you'll get this message sent to your delegate. Map view, annotation view, callout accessory tapped. So this keeps you from having to make target action and all that stuff from something that's a button inside your callout view, right? Because you just put the button in there, no target action, and then this method will get called every time someone touches on it in a callout. So we're talking about in the callouts now. All right? So don't get this method confused with the did select annotation view method. That's a different one. That's if they clicked on the pin. This is if they clicked on a button that's in the callout. So oftentimes the things that are in the callout, the left and right accessory views, we won't set those up until did select annotation view happens. Okay? Because we might have 100 pins on the screen to start, and we don't want to make a whole bunch of, download a bunch of Flickr images for all of their images in their callouts until one of them actually gets clicked on and their callout appears. Do you understand what I'm saying? Okay, so we would not want to load up the mem_chu image in all the callouts of all the pins in view for annotation. We want to load it up here in did select annotation view. One thing to note there, you see the little comment. If you here, for example, we're using GCD to load the Flickr image thumbnail, which you're going to have to do for your homework, in another thread. Be careful when that thread returns, because you got to remember these pins are reused, okay? And they might have clicked on somewhere else and scrolled away, and that thing might now be that view that originally you were asked to select this annotation view might be long gone by the time that Flickr thing comes back. So you're going to have to do some kind of checking when it comes back, when your Flickr image comes back, to make sure that the world is still the way it was when you left. Okay? So I leave that as an exercise to the reader because I want you to understand what's going on with threads. You can't just willy-nilly assume the world's going to be the same when you come back from a thread. So you're going to have to do a little bit of testing here to make sure things are still the same before you just say image view image equals whatever. Notice also that aview.left callout accessory view, I'm doing a little introspection here, is kind of class, UI image view class. You don't necessarily have to do this. I mean, you wrote the view for annotation delegate method, and you either made the left callout accessory be a UI image view or you didn't. But, for flexibility, for protection, since the failure here is that if it's not a UI view, I just do nothing, it's not so bad to do a little bit of introspection here. Okay? Or you might have a situation where some of your callouts have a UI image view as their left callout accessory view, and some of them have some other kind of view, in which case you definitely would need introspection. So there's a whole bunch of methods to configure the map's display type. One of the extra credit items is to show satellite mode map, or a hybrid between street mode and satellite mode, so you can play with this map type property. You can also show the user's location, the user's current location on there with a special pin. And you can also control zooming and scrolling on the map. If you just want a fixed map that you don't want the user to be able to scroll around on, you can do that. You can also control the region of the world that is being displayed by setting the region property on the map view. And you can see that it's just a coordinate 2D, which is latitude and longitude, and a span. All right? The span is just how far in latitude, right? And this is the total span of the region. So the center is in the center, and then the region has a certain span. And so when you set the region, the map will scroll and zoom to show that region of the world. Okay? And so on your assignment, you also have to do that. You can also just set the center point only if you just want to scroll and not zoom. You get notifications to your delegate when the map starts loading. Remember that it's the entire world's satellite imagery is not on your phone. Okay, so when you scroll around, it's downloading from Google Maps all the map information. Okay, so it kind of comes in tiles, and so this will tell you when it starts going back out to the network for more, and when it finishes. So you'll be constantly getting start and finish. Usually you don't care about this, but if you do, there you go. There's also a ton of C functions. Really don't miss this. There's a lot of C functions like mkMapRect contains point and mkMapPoint for coordinate for converting between map coordinates, world coordinates, etc. So check out all these C functions that start with mk. Okay, question?
Do we have to use only Google Maps, or can we use, like, access other maps as well?
So the question is, do we have to use only Google Maps, or can we access other maps in addition? This API always gives you Google Maps. Okay. At least that's what it currently does, I suppose. That could change in the future, but bottom line is you don't know where the maps are coming from. Overlays I don't have time to talk about, but you can think of an overlay as very similar to an annotation, except for that instead of just drawing an image and you click on it, you actually can implement a draw rect, essentially. Okay, so you can draw, overlay the map. And usually overlays are larger, right? They're not at a single point, right? They're going to be some overlay of a route or something like that, and you're going to actually be drawing it. You set the overlays in the same ways you do annotations, right? You add overlays and remove overlays. And then there's also the same mechanism like cell for row at index path or view for annotation, where it's going to say, oh, here's an overlay, give me an MK overlay view. And now an MK overlay view is something that basically implements a draw rect-like thing. It's not called draw rect, it's draw map rect with zoom scale in context. So notice you're getting the drawing context here. So it's different than draw rect in that you don't call UI graphics get current context. It gives you the context. Then you do your core graphics drawing. There's some methods also that will convert points. I told you about the C functions. There's also methods that will do it, which are a little more useful and needed when you're doing overlay views, because you're kind of always converting back and forth. All right, so it's demo time. I think we have enough time to do this demo. What I'm going to do is I'm going to take the Shutterbug thing we had from last time, and I'm going to put it in a split view, and I'm going to have the detail side be a map of what's in the master. Right? That's what I'm going to do. All right, let's see, where are we going here? There we go. Okay, so this is the Shutterbug from last time, right? I haven't changed it. This is not the sections one, this is the normal one. In fact, let's go ahead and, actually, let's see if our device is working today. Had a little trouble with it last time. Hopefully the network is working today. Just to remind us where we were last time. Here it is. Okay, so we have this table view. We hit refresh. Looks like it's working this time. You can see we got a little GCD going on there. And here's our list of photos. Okay, just recent georeference photos. So what we're going to do, I'm going to put this in a split view, and all this information that's in this list, I'm going to have it be in a map, the detail. So let's do that. So let's start by doing the storyboard work. All right, so this is what we have now, and I'm just going to go over here to the object library. Now, as I'm doing these storyboard things, this is something you really want to pay attention to. I know it's really hard. You watch it, and then you go away, and you're like, how did he do that? But this stuff that I'm going to be doing today, you should have already done both in assignment 3 and again in assignment 4. Okay, so this should be very familiar to you. So I'm just going to take a split view, drop it in here. Oops, missed. Drop it in here. I'm also going to make some more space for us here. You know, it gave me this stuff, which I don't need because I've already got this. So this is the master side, and I'm just going to use what I already have, so I'm going to delete that. Let's pull our existing master up here, right? And I'm just going to control drag from my split view to set up my master here. So this is control drag, relationship master, so that makes it the master. Also, you see this little arrow right here? That's the thing that says, where are we going to start this app? I want to move it back here. I know some of you missed that little detail, that we want to start with the split view. We don't want to start with this as our root controller. Yeah, question?
So if you actually if you have another view and you delete the one with the root controller, how do you get it back?
How do you get the root arrow? The root arrow will always attach to something, okay? If you delete something that's the root arrow, it'll jump onto something else. And I've never seen it not do that. Even if you delete all of them, as soon as you create one, it'll jump onto something. But if you did lose it all the way, you can always set that by going here. If you click on a view controller, there's always this thing right here, is initial view controller. You see how that's set for this one, not set for this one. So anyway, so that's that. Now our detail is going to be different. So our detail is going to be a new view controller that's going to be controlling the map. So I'm going to go up here to my File menu and create a new view controller subclass. I'm going to call it Map View Controller. It's a UI view controller, not a table view controller. It's just going to have the map. This is the only view it's going to have. Make sure you put it in the right place. It is. So there's our map view controller. I'm going to make sure that I go here and set the class of this thing to be map view controller. And I'll just go ahead and build its view right now too. So I'm going to build its view by just getting a map. And if you scroll down in the object library down here, you're going to see this thing map view. All right, so let's drag this out. Put this in here. Make sure we position it to fit. Always nice to check struts and springs. That's the struts and springs I want. Let's go ahead and create an outlet for that thing, for this map view. So let's go to my map view controller. Let's go ahead and make this a private outlet. So I'm going to do the little private interface thing here. Hopefully, again, this is all quite familiar to you all. All right, so I got a private interface. Now I can just hold down Control and drag to create an outlet. Right? I'm going to call it map view. Okay, and it's automatically created a synthesize for me. It even added something down into view did unload down there. Notice I have an error here, this red error. This is very important, okay? If you're napping, wake up right now, okay? Very, very important. The reason this red arrow is happening here is because we're using MKMapView, which is in a framework that's not linked into this app. Okay, the MapKit is not by default linked in like UIKit and Foundation is. So how do we get that to happen? All right, very simple. We go back to our project navigator, click on our project. I'll even make it fully wide here. So here's our project, and so we can inspect either the project here or the actual app, and you want to click on the target. And then you go over to build phases, and this is where your linking happens right here. So if you look at link binary with libraries, you can see we only link with UIKit, Foundation, and Core Graphics. Right, so we need to add MapKit, and we just do that with this little plus button right here. So it's project, target, build phases. Okay, and then link binary with library. So we hit plus here. You can see there's quite a few frameworks. That's why if you feel like I've shown you a lot this quarter, we're only just getting started. Okay, there's a lot to learn here. Many, many, many frameworks. This one we're going to do MapKit. A lot of times when I'm doing MapKit, I also like to grab core location. You don't really need the core location framework unless you start using some of the core location functions to manipulate things, but they kind of go together a little bit, core location and MapKit. You probably don't need core location for your homework, but it can't really hurt to link it in. The cost of linking in a framework is very, very low. Okay. All right, so back to our map view controller. Now this little red thing will go away if I just say import mapkit/mapkit.h. Okay, and you can see that our outlet is connected. That's good. One thing I always like to do in an MVC, I told you this last time, I like to put its model in there. And so the model that I'm going to create for my map view controller is an array of annotations. Okay. All right, so I'm just putting that comment in so anyone looking at the public API from my controller understands that my model here is the annotations. And I'm just going to end up passing these right on to the map view, but since I don't make the map view public, I need to have some public API so someone can set my annotations. I need to go over here and synthesize my model, which is annotations equals underbar annotations. I'm going to fix what Xcode did for me to make sure that I have a different named instance variable for this property as well. And then one other thing I'm going to do here with, which I know some of you kind of missed this step a little bit in the homeworks, is whenever I have my view and my model settable like this, I'm going to make sure they're always in sync. And I'm going to do that in the setters of both. So for the map view setter, I'm going to obviously set my map view. And then I'm going to call a method which is like update map view, let's say. Okay, and then I'm going to do the exact same thing in the setter for my public API. This way, no matter what order my model is set compared to my outlets, right? If someone sets the model before my outlets get set, or if my outlets gets set first, and then my the other way around, then I'm going to update. So I have to implement this thing here, update map view, of course. And all I want to do here is, if my map view has any current annotations, then I'm going to remove all my annotations, because I'm going to replace all of any annotations that are in there. And then if I have any new annotations, then I'm going to add those. So here's where we're adding and removing annotations. Okay? Question in the back.
When you're segueing, the view gets created from the heap, so why would you want to do this in that case?
So the question is, when you segue, I didn't quite get the thing you're saying about the view gets created. Well, yeah, I mean, when you one thing that's annoying actually about segues, you've probably noticed this, in prepare for segue : sender, your outlets are not set. Okay? So, for example, if I were segueing to this map view controller, I couldn't just make map view public and just say this thing dot map view dot annotations, add annotations, whatever, because my map view outlet is not set in prepare for segue. So this is a classic example why you want to do this, because in my segue I'm just going to set the annotations, and then later on when that map view outlet gets set, bam, the annotations will get added to it. Does that make sense? Okay, so basically another way to think of this is I'm keeping my model and my view in sync. So no matter which gets set, they're always going to get updated to each other. Okay? All right, so the next thing we want to think about is when are we going to call this public API and set these annotations right here? Okay? And the answer is this is in a split view, at least so far. This is in a split view. So basically whenever the list in the master changes, I need to change the detail. Everyone agree with that? So it's basically when I hit refresh. That list is going to change. Boom, I need to change this. So let's go back to where refresh happens. Here's refresh. Okay? And in fact, even more than refresh, more generally, every time my list of photos changes for any reason, even if it wasn't refresh, somebody just set my photos or whatever, I might want to make sure that I react to that by updating my detail view. So this might be a good place to say something right here like self update split view detail. And then I would have a method here, split view detail. And this would get the split view detail, which you'll remember is self.splitViewController.viewControllers last object. And then I might even be kind of protective. Let's import map view controller here. Might be a little bit protective here and say if the detail is kind of class map view, then I'll have a little local variable here, map VC, not MVC, map VC equals map view controller star detail. Okay, so now I've got my little map view controller, and I would just say map VC dot annotations equals, let's say self map annotations. I'll have another method here, which is just going to be an NSArray, map annotations, and we'll have it return nil for now because we have to figure out how to implement that. And it's just going to return those annotations. Okay, so everyone understand how I'm going to do this? So now the question is how do I implement this map annotations? Well, we know that the map annotations array is an array of what? ID MK annotation, right? So we need some objects that implement the MK annotation protocol. Okay, so that's the next thing we're going to do. And this is the first time, and you're going to have to do this in your homework, and this will be the first time that you probably had to create a new class. Some of you might have done this on some of the previous homeworks, but for a lot of you, since calculator brain, this is the first time you have to create a new class. This is just a direct subclass of NS object. Okay, so I'm going to create a new class, right? New file, Objective-C class. It's going to be a subclass of NS object. I'm going to call it Flickr photo annotation. Okay? So it's just an NS object called Flickr photo annotation. And one of the first things I'm going to do is go into its public header file and let people know that this is going to be an MK annotation. Okay, I'm going to need to import MapKit. Okay. Now, the interesting thing about this MK annotation protocol is you're going to ask the question, and it's a good one. You should be thinking this might be too early, but you should be thinking this are these Flickr photo annotation objects part of my model, my controller, or my view? Okay? And the answer here is these are part of your controller. There's nothing in MK annotation that has anything to do with UI. It's not part of your view. But this is also not part of your model. Our model here, the model for our Flickr photo table is this array of NS dictionaries of Flickr data. Okay? There's nothing about that's MK annotation. So you can think of the MK annotation as like a bridge that your controller makes. It's in the controller camp, a bridge between your model and your view. The view being the MK map view, the model being that array of NS dictionaries from Flickr, right? So this thing is just going to basically provide a portal, a way to look at that model in a way that the view wants to see it. That make sense? Okay. So if we remember that an MK annotation has title, subtitle, and coordinate, so we'll do those in a moment. I'm also going to add a nice little kind of helper method which creates a new one of these things. I'm going to call it annotation for photo. Takes a Flickr photo. I'm even going to comment that and say photo is Flickr photo dictionary. All right? So I'm going to have this as well. Notice I don't have to declare NS string subtitle, title here. That's automatically implicitly declared by the fact that I publicly implement this protocol. So I don't have to put those in my header file. I have to put them in my implementation because I'm required to implement this protocol, but I wouldn't put them here usually. Okay? So the implementation is pretty straightforward. One other thing I'm going to add, let's add another public property here. How about non-atomic strong NS dictionary photo. This will just be the photo. This same photo is this. We'll make it back available to them. Or people could create this Flickr photo annotation using alloc init and then just use this property to set the photo. This is just going to be a convenience method to do that. So let's go over here. Let's synthesize that photo thing. Let's put this little fun convenience method. Oops. All this thing is going to do is just create Flickr photo annotation by saying Flickr photo annotation alloc init, and then it's going to say annotation.photo equals photo, return the annotation. Okay, so sometimes it's nice to put this little convenience method like this just to make it easy for someone to create an annotation for a given Flickr photo. Okay. All right, so now let's go ahead and implement MK annotation. This is going to be really easy to implement. So we got title. That's just going to return self.photo object for key. We need Flickr fetcher here. Import. This is one feature I always wanted in Xcode is automatically put the imports in. When you start, when I start typing a thing here, it should know it's there. It's parsed all my header files, and it should just automatically add the import for me, maybe in the future. So there's the title, right? And then here I'm going to get the subtitle. Okay, I'm going to just return self.photo value for key path. Hopefully you all got that in the homework. That's Flickr's photo description. And then lastly, we have CL location coordinate 2D. Okay, now here's how I'm going to implement that. I'm going to create a local variable. Oops. And then I'm going to set this local variable's latitude equals something, and I'm going to set its longitude equals something. Now remember, those are doubles, all right? Now you're going to ask, where the heck do I get the latitude and longitude out of that photo dictionary? And the answer is, there's two keys in there, latitude and longitude. And in fact, I'm going to go over here to flickrfetcher.h and add those, and you probably want to do this too. So again, wake up if you're snoozing. Maybe put something like Flickr latitude in here, and it's just latitude. Okay, now this key is in both photo dictionaries and place dictionaries. Okay, so whether you're trying to get the latitude and longitude of a place or a photo, that's why I called it Flickr latitude instead of Flickr photo latitude, okay, because it applies to both. And I'll do the same thing for longitude. Okay, so now I have those nicely added to my Flickr fetcher. So now when we go back here, I can just say self.photo, object for key, Flickr latitude. This is not quite right, as we'll see. Luckily, compiler catches it for us. Flickr longitude. Okay, so why is this not right? That's because this is returning an object, not a double. Okay, in fact, it'll be an NS number. But we all know how to turn an NS number into a double. We just send it double value. Same thing here. Okay? All right. So now I've successfully added this new class, Flickr Photo Annotation, and it implements the full MK annotation protocol and also provides this nice thing. I see my warning this time. I'm not ignoring it like I did last time, much to my peril. So I better return that coordinate, that little local variable. All right, so this is good. So now we have a way to create an annotation that represents a Flickr photo that's on the left. So now all we need to do in our map view controller is set our list of annotations. So if we go back to here, and we're trying to create this list of map annotations, I'm going to do this by just saying ns mutable array annotations equals ns mutable array array. Okay, so I'm creating one. I could actually do array with capacity here and give it a little hint. Remember, array with capacity is just a hint as to the size, because I actually know the size here. Okay, it's the number of photos I have, because I'm going to have one annotation for every photo. So I can actually, do a little performance hint there. Totally optional. If you don't have to, if you want to. So now let's just go through all of our photos. We'll just use fast enumeration here. And I'm just going to say annotations, add object. Better go do another automatic import here. Flickr photo annotation, that's our new class. So I'm just going to say Flickr photo annotation, that nice little factory method I created for it. Photo. Okay, so that creates the annotations. Return annotations. Okay? Everybody follow what we did there? So hopefully if I haven't forgotten anything, look at my notes. Question, anybody notice? Yeah, so someone's noting that this is an NS array, but here I'm returning a mutable array, and that's okay, because an NS mutable array is a NS array, so I can pass it through. It's perfectly fine. You could argue someone could do is kind of and then start manipulating it, but if people do that, they get what they deserve. Okay. So let's go see if this works. Hopefully I won't have to do more than one iteration here to get going on this one. I've hopefully done this right from the start. All right, so here's my map. Let's rotate here. Oh, I know the problem. So here's a good one for your homeworks. You might have noticed this too. See, so, I can't rotate. I haven't implemented the split view delegate either, so I have no button, so I can't get at my UI. And why does this happen? Anyone want to guess before I tell you? Why can't I rotate? Auto rotation, exactly. So if I go down here and look at my should auto rotate, it only allows, portrait. Well, that's no good. So I'm just going to say yes, because my map view can rotate to any thing. So let's go see if that gets us going. Gets us a little farther anyway. So that's a common one with the split view, to think, oh, well, why is this not rotating? And that's why. So, all right, so here we have a map. Now we're rotating. That's good. So here I have my map. It has no pins on it, but I can zoom in and out and swipe around. Go to Europe, wherever. Okay, hit refresh. Okay, so now we're loading the stuff. It works. Oh, and then there's my annotations right away. Okay, so that was really nice. Now, as I scroll around here, these pins that are over in California, when they come off, they go into a DQ. They go into the queue, and then as I scroll over here to Asia, they come back on in Asia. Okay, so it's reusing those pins, and you can see it's very highly performant. And if I click on a pin, so I'm just going to press on one, you can see that by default I get the title and subtitle from the photo. Okay, so that's pretty cool. That's a good start. What's next? So next, let's go ahead and see if we can add the photo image as the left accessory view inside that callout. Okay, so to do that, the most important thing, I'm going to clean out some of this code here just again so that in the demo you're seeing only the code that I'm actually adding. To do that, one of the most important thing we need to do is for the map view controller to be its map view's delegate. Okay, because we need to get involved in the process here, and that's what the delegate does. So I'm just going to, let's say, view did load is a good place to do this. Super view did load. And then I'm going to say self.mapView.delegate equals self. That's going to give me a warning, of course, because I haven't said that I implement that. No problem. I'll go up here and say that I am an MK MapView delegate. All the methods in MK MapView delegate are optional, so I'm not getting a warning of incomplete implementation or anything. But I am going to implement one, and I'm going to implement really the most important one, which is the thing that returns an MK annotation view for a given annotation, right? This is like self or row at index path that I talked about. Question?
Does it cause problems if you don't call super view did load?
The question is, does it cause problems if you don't call super view did load? And the answer is, it might not, but it might, okay? So the thing is, always do it. All the view wills, view did, call super, okay?
If you override it and you subclass it and you want to override that again, but you don't want to call the super
Well,
class.
okay, so the question is, if I override a subclass and then I don't want it to call super, well, okay, you better know what you're doing if you're not going to call super, because you're inheriting from yet another class, UI table view controller, or whatever. In this case, UI view controller. Map view is inheriting from you. It might want to do something in view did load, and if you don't give it a chance, it might not work. So my point is, it's defined that you're supposed to do it for all the view controller lifecycle. So don't do it at your peril. All right, so this is MapView's main delegate method to get us a view for a given annotation. It's called view for annotation. We simply do this little dance similar to how we do in table view, which is, I don't even want to say that. I'm going to say MapView, which is the sender right here to this method. DQ, I'm going to call my reusable things MapVC. Again, I can put any string there as long as I'm consistent about it. And if that doesn't return anything, there's nothing to reuse, then I'm going to create my thing by using alloc init. I'm going to use pin, annotation view, alloc, init with annotation, not coder. I'll talk about that on Thursday. Annotation, reuse identifier, mapvc. And then I definitely want to call out, so I'm going to say aview.canShowCallout equals yes. And then down here, in case I was dequeuing, I want to set the annotation to be this annotation. So yes, I set it twice if I don't dequeue, but who cares? And then we're going to return the view. All right. So the code that I've done so far is going to do the exact same thing. So I'm short on time here, so take my word for it. If I ran it, it would do exactly the same thing. So the code you see here, that's the code you get if you don't implement this. All right. But we want to do more than this. Most specifically, we want a little UI image view to be in those callouts. Okay, and we want that UI image view to have the photo's image. And we do that by adding a left callout accessory view, which is a UI image view. Now, one thing that is really kind of gross about this is you probably want to pick a hardwired size for that little call out, and 3030 is really good, so I recommend it. And that's really, this is not good, because if in the future they change the font size of the default call out or something, now your image might be too small or something like that. But I've never found the API anywhere in iOS that kind of gives me the size of the call out, so I know what size to make my accessory views. So as far as I know, there's no other way to make this look nice except for to hardwire it, and the homework specifically allows you to hardwire it. But normally this would be bad coding, right? To put the number 30 anywhere in your code would be bad, okay? But in this case, we don't really have any other way to do it. Now, remember, this only happens if we create the thing. If we dequeued, we'd want to set that image to something else. So you might be thinking that I need some code right here, which is aview.left callout accessory view, send it some message like set image something, okay? But I really don't want to set this image to something because I'm only creating the pin view here. I don't want to be like downloading an image from Flickr here, okay, because I might have hundreds of pins. Okay, I only want to download for image from Flickr, for example, do something expensive when someone clicks on the pin. So we're going to do that in a different method, the I just clicked on a pin delegate method. The other thing too here is, how do I know to send it? This compiler's complaining. It's like, what's going on here? This is a UI view. You can't send it set image. So we would have to cast here. We would have to say UI image view, call out set image. Okay. Now, again, do you want to do introspection and say is kind of before you would do something like this? You might or you might not. It depends whether you always do this or not and how much you want to defend against that. But notice I am going to leave it in here that I set it to nil. And why is that? Because what if I reuse a pin that had an image in it? I don't want that thing, its call out to come up with some random photo from somewhere else in Asia, okay, when I'm in California. So I'm going to set it to nil. That makes it go away. Then I'm going to put it back when someone touches on the pin, which is this method, map view. You can see there's quite a few map view delegate methods here, right? I'm going to pick this one right here, did select annotation view. Okay? So that's the thing that is sent when someone clicks on the pin. The pin is the annotation view, and it's going to put up the call out. All right? Now, how am I going to get this image? So I basically want to do this right here. But instead of image nil, I want the image to equal something. So I want UI image star image equals something. Okay? So how am I going to get this image? Now, this is an interesting kind of, sorry, this also is view here instead of a view. This is an interesting object-oriented programming thing here because so far I have a completely generic map view controller, right? It knows nothing about Flickr. If I look at my imports, there's no Flickr here. No Flickr, it's Flickr free, okay? So we don't want to put any Flickr in here unnecessarily. So what do you do when you have a generic class and you want it to get data from another class? I heard two good answers. One, subclass. Yeah, I could subclass. I could definitely say Flickr map controller view, which is a subclass of this. Delegation, though, probably even better here. So let's do, this is going to be high-speed delegation because I only have 5 minutes left. So here we go. So I'm going to create a protocol. I'm going to call it my map view controller delegate protocol. It's going to have one method in it, which gives me a UI image, right, for a given annotation. I'm going to call it map view controller star sender image for annotation. That's what I'm going to call this little guy. And what it's going to do is it's just going to ask this. We're going to ask this delegate anytime we want an image to go in a call out. So really nice and general. Let's fix the error here, which is we need to forward declare map view controller. Now we just need to add a property, which is our delegate, right? Non-atomic weak all the time. It's an ID map view controller delegate. Right? I'm going fast here because hopefully you've seen these things before. We also need to import MapKit because we're using MK annotation now in this header. Okay. This is because we need to synthesize it, so let's do that. All right. So now we got that. So now let's use it. We're going to use the delegate. I'm just going to say self.delegate image. What did I call it? Map view controller image for annotation. What is the annotation here? It's aview.annotation. Okay, and aview is passed into us here because we selected an annotation view, a pin, and all these pins know the annotation that they're displaying. So now we've got this. If the delegate is nil, that's fine. This will be nil. This will be nil. All winning. Okay, so if we don't have a delegate, we're perfectly fine here. And so now here we got to set the delegate. Great place to set the delegate is just right here. We might be setting it multiple times because the detail controller, we might be updating it all the time, but that's okay. equals self. Of course, to say self, we need to implement it ourselves. So let's copy and paste here, and have a little private. We'll make this private that we do this. Clean out this. All right. This is the map view controller delegate protocol. And now we're going to get a warning here that says we don't implement everything we need to because that's a required method in there. So we better implement that. And so we have UI image, map view controller image for annotation. How are we going to get the annotation? Real easy, actually, because the annotation, it has the photo dictionary on it. So I'm just going to say Flickr photo annotation star FPA. Equals Flickr photo annotation star annotation. Again, maybe I want to do introspection here, possibly, to see if this annotation truly is a Flickr, photo annotation. But for expediency, I won't do it here. So let's get the URL. Is just fpa.photo. Flickr fetcher. URL for photo, fpa.photo. Format is Flickr photo format large, not large, we're doing thumbnails here, right? There's little thumbnail images, so we want square. Okay, that's a little hint to you. You would definitely want square. You don't want a gigantic image shrunk down into that little call out. Then we want NS data. The data for this is just NS data. You're surely familiar with this now. Data with contents of URL, the URL. And then we'll just return UI image, image with data, the data. And we might want to say something here like data ? That else nil, mostly because I'm not always want to be confident that if I call this with nil, it's not going to cause a problem. Probably won't, but just to be safe, why not? So, anyway, so now we're getting the image from the map view controller, and hopefully this will work. Sorry to have to rush it a little bit at the end there, but. All right, so hit refresh. Get our list, okay? We have all of our things here. Let's pick on a pin, and you can see we get the little image. You see the tiny little image there? What you call a preview. You see that? Now, the only thing about this is Stanford's network is super fast, so these things are popping up immediately. If you were on a slower network, downloading that Flickr image might be taking a little while, in which case you'd click and it's like, where's my thing? It's too slow. So that's why you would likely, and for your homework definitely, want to put that little image fetching in a thread, okay? But when that thread's done running, this call out better still be the call out that's showing for that annotation, or you'll be putting the photo on some other annotations thing, okay? So be careful about that. Okay? That's all I have today. Thank you very much. I'll be here a little bit afterwards.
For more, please visit us at stanford.edu.